Good morning, everyone. Welcome to One Concept Per Day portal. This is the fourth problem of the series in electricity, that is on electric circuits. This question has been taken from 2024 November paper, the recent one. And prior to it, we have seen several other questions, three questions we have seen. So before you watch this one, so go through the previous papers also. This will really help you in understanding the concept very well, and it will help you in solving the rest of the problems. Okay. Now let us continue with this one here. So two resistors X and Y are connected in series to a cell of EMF and negligible internal resistance. X and resistance of X and Y are constant. Okay, so it is not varying. The power dissipated in X is greater than that in Y. So whenever statements like this is given, you better write down this value. So you can say Px is greater than Py. Okay, now you see the same current I will flow here on all both X and Y. Okay, then state and explain how the resistance of X compares with the resistance of Y. Is for 2 marks. So when you say Px is greater than Y, which means how do you find out what is Px over here? The same current passes like this. So I can now write I squared multiplied by Rx is greater than I squared multiplied by Ry, where Rx and Ry are the resistances of X and Y. So now you see this I square and I square goes away. You can write Rx is greater than Ry. Rx is greater than Ry. So I need to write 2 points over here. The first point is Px greater than Py is given, and since it is a, see, if you just write Px greater than Py, nobody will give you a mark. Okay, if it is a series circuit, excuse me, series circuit, we have current Ix is equal to Iy, 1 mark. Second one, Px greater than Py implies Ix square greater than, Ix square, I square into Rx is greater than I squared into Ry, which implies Rx is greater than Ry. Okay, so we have mentioned this. Next, X and Y are now connected in parallel to the same circuit. Okay, so let us explain which resistor has the greatest power dissipation. Very easy. So now this is your Rx, this is your Ry, and what we have done, we already know Rx is greater than Ry. Okay, so how many marks is this? 2 marks. Let us explain which resistor has the greatest power dissipation. First mark would be identifying what kind of circuit is this. Since it is a parallel circuit, power dissipated across X and Y can be written as R, can be written as Px is equal to V square by R. This is E here, so I will write E square by Rx. E square by Rx, and Py is equal to E square divided by Ry. First point. Second mark. Since Rx is greater than Ry, therefore Px would be less than Py. Okay, done. We have compared it and we have written the whole thing down. Now let us move on to the next one. A lamp Z and a resistor R have the IV characteristics shown in the graph. Okay. Is he referring to the same circuit? He is not referring to the same circuit. Okay, now it's continued. Describe the variation with voltage of the resistance of Z. Describe the voltage variation, okay, with resistance of Z. Now, so what's happening with respect to Z, we have to talk. See, these are not parallel lines. Okay, these are now making some angle. So let us determine the angle over here. If I take this angle, let me call this as theta1, and at the same position, for example, here, this I will call this as theta2. So what can you comment on this theta1 and theta2? You can say this theta1 is larger than theta2, right? Because you see, this is much larger, this is much smaller over here. Theta1 less than theta2, which means your tan theta1 would be greater than tan theta2. What is tan theta1 in a graph? This is nothing but slope. So what I will write is, I will write this as slope of Z is greater than slope of R. Slope of R. I'll write like this. Now let us understand what is slope here. The slope here for any of these lines is nothing but delta I divided by delta V. Okay, but we know that delta V divided by delta I is equal to resistance R. So therefore this should now be equal to 1 by resistance. Now we have got all the informations from the graph. Now we need to write over here. Describe the variation with the voltage of the resistance of Z. Okay, what's happening to the resistance of Z when the voltage is increasing or decreasing? That's what we need to write. So towards it, what we have to write is we will say as first one, as voltage V increases, as voltage V increases. See here, as voltage V increases, when voltage V is increasing like this, what's happening to the current? The rate at which the current is increasing is higher as compared to V, right? So you can say the rate at which current increases for Z as compared to R, okay? So this one thing. So therefore your delta V by delta I for Z is, what's happening here? We have already seen slope is higher here, which means R is lower. R is lower over here. R is lower, is decreasing. You can also get it from here. When I is increasing, that means what happens? This denominator now starts reducing. So delta V by, so denominator starts increasing. So 1 by denominator reduces. So this delta Y by delta I of Z is decreasing. Or you can say resistance of Z is decreasing or increasing voltage. Okay. Now let us move on to the next one. R and Z are connected in series to a cell of EMF 12 volt and negligible internal resistance. Determine using the graph the power dissipated in lamp Z. What is the power dissipated over here? So how do we do? Series circuit. Whenever there is a series circuit, your power dissipated can be calculated by two methods. In fact, you can do it by three methods. But easiest way is to find by two methods. One is you can say this should be VZ IZ, or you can say IZ square multiplied by RZ. Okay, you can do by either of them. Determine using the graph the power dissipated in lamp Z. Okay, now we need to determine either IZ and then get the value of RZ and do it, or you need to get the value of VZ and IZ. Whichever is convenient for you, you can do with it. Now let us go back to this. So now what is the clue given here? The clue given here is there is a current which comes like this over here. The same current passes through R, same current passes through Z also. Now let me go back to this graph. Same current passes through R, same current passes through Z also. If I draw a line anywhere over here, if I draw a line like this over here, what does it tell you? Same current passes here, same current passes here. Okay, but there is a difference in the voltages like this over here. There's a difference in the voltage over here. So what does this tell you? Now if you look at this voltage over here, what is this voltage? This is VZ. VZ will be equal to 2 volt over here. I have just drawn an abrupt line. Okay, I did not take up any problem here. I took VZ equal to 2 volt over here. And what is this now? This should be VR. This is for R over here, right? This line intersects over here. So somewhere over here, not here, it's somewhere over here. So this is your 4, this is your 6. So this should be 5. This should be around 4, 4.5, 4.75. So this should be around 4.75. Okay. Now what is that it is giving me? That's what the question we need to ask. Now let me go back to the circuit. If 12 volt is the voltage given here, then this 12 volt should be equal to VR plus VZ. Okay, I do not know how much will this get dropped over here. This can be 6 plus 6, this could be 4 plus 8, whatever it is. Okay, I do not know. So therefore, such that the sum of these two should be equal to 12 volt. Now what we have here is that when I add these two voltages, 2 volt and 4.75, the total voltage I get is 6.75. Okay, so therefore, this current that I have taken here is incorrect. Okay, this cannot be the right current. I should take one such current wherein the sum of the voltages should be equal to 12 volt. Okay, got it? Okay, this is very similar to the problems that we have done in case of the graphical analysis here. We look at this paper over here. So here also we did a similar one. But what did we do here? We found out the total current. Okay, now we are doing the reverse of it. Okay, total voltage we are doing. Okay, now let me go back to this. Now we want the sum of the voltage to be 12 volt. Keep that in mind. Now let us start with this. So we have seen from here. Now what we will do, let me take up another voltage. What is this now current over here? This current I have taken 30 over here. Okay, 30 did not work. Let us take up 60 here. Now, if I take 60, now I will draw a line here. This cuts here and this cuts here also. This cuts here. See, any other line beyond this is of no use, because this line truncates over here. So therefore 60 would be the maximum. So I am taking the maximum now. So therefore, if you take this voltage here, what will this voltage be? This voltage would be, let me come over here. This is your 9, this would be 9.5. Okay. If this is 9.5, this should be 0.5. So that, sorry, 9.5, this should be 2.5 or something. But you see here, what is this value? This value you are getting this as around 5 over here. So 9 plus 5, 9.5 plus 5 will be 14.5. But supply voltage is only 12 volt. Okay. So therefore, this line is also incorrect. So which means the current that you are looking for, okay, should lie between these two lines only. Okay, it cannot be lower than this, because if I go below this one, definitely the voltages will also reduce. So that's not the right answer. So now it should be between this. Now let me try with this 40 here. Now once again I will draw a line here. It will intersect these 2 points. It is intersecting here. What is the voltage here? This voltage is 2, this is 3. This should be 3 here. And where is this? This line, right? This line, once again, it intersects this point. This is your 6, this is your 7. This should be around 6.5. 6.513. 6.513. What's the sum? 9.5. 9.5 is not the right answer, because I need 12 over there, right? Sum of the voltage is 12 volt. So definitely this is not the right one. This is also not the right one. So we have seen 30, 40, 60. Let me take up this one also. If I take this value here, what is this value? This is now intersecting at 4. So Vz is equal to 4 over here, right? Which one is this? Yeah, this Vz equal to 4 volt. This is 4 volt over here. And if I extend this line, it will intersect at this point. This is 8 volt. Wow, we have got this. This is 8 volt. It's 4 and 8. So 4 plus 8 gives us to 12 volt, right? So therefore, the corresponding current is now equal to 50 milliampere. So we will write down here. We'll write down here that, so using the power we have, so therefore the corresponding current is equal to 50 milliampere. The resistance, the voltage across R, let me look at this. The voltage across R here is seen to be, what is this now? This point is Z over here. Voltage across R is seen to be 8 volt. Okay, and the voltage across the resistance R, Z is equal to 4 volt. So VR equal to 8, VZ equal to 4. Let me just write it out here. Right, VR is equal to 8 volt, and this should be equal to 12 volt. Sorry, 4 volt. 4 volt. So this is now happening over here, and the current at these voltages is seen to be 50 milliamps. You got this. Now what's the next step? The next step is you need to find out what is the power here. So which one can I use? I can use this equation here, right? This equation, what do? I write PZ. I want the value of PZ over here, which should be equal to VZ into IZ. What is VZ? VZ is 4. What is IZ? 50 milliamperes. 50 milliampere. Then it should be equal to 200 milliwatt. So how much will this be? It will be 0.2 watt, right? So thus 0.2 watt is the correct answer to this. Okay, so with this we come to an end to all the problems. I hope you like this series. Okay, so write back to me, and if you are in need of any other concept, we will definitely discuss that also here. I'll take up the relevant problems and we'll do it. Thank you for patiently being with me for a long time, because this video I solved this within 2-3 minutes, but okay, I had to extend it. If you have understood it, it's fine. Otherwise, let me know. Okay, so I can write down in the comment section. I'll definitely be able to help you out with this. Thank you. So before you leave, please do share, like, and subscribe to my channel for more updates. Thank you.